Hello students, today I am going to take up a few more properties of definite integrals. In my previous video I had taken up a few properties. So let's just quickly do a quick recap of those properties. The first property, which we called as P0, it states that the integral from a to b fx dx is equal to integral from a to b ft dt. That is, the function remaining the same and the variables and the limits of integrals remaining the same. The change in variable, whether we use x or we use t, has no impact on the value of the integral as long as the function to be integrated is the same and the limits are the same. The second property, that is P1 property, is that a to b fx dx is equal to minus of integral of b to a fx dx. That is, if we swap the limits of integrals, then the value of integral becomes negative of the original value. So here in this case the function is the same, variable of integration is also same. The only difference is the position of the limits. The upper limit has become the lower and the lower has become the upper, and the value of integral has become negative of the original value. In the third one, if c is any point lying between the limits a and b, then we can split the given integral into two integrals, one from a to c and the other from c to b. The function remains the same, variable of integration remains the same. This property can further be extended to more than one points lying in the interval a to b. So that is, if we have c1, c2, c3, suppose, in the same order lying between a and b, then the function, this integral, can be split into one integral from a to c1, then from c1 to c2, then c2 to c3 and c3 to b, and the function is the same, the variable of integration remains the same. These were the basic properties. Now let's move on to the next property, which we call as P3. It says that a to b fx dx is equal to integral from a to b f of a plus b minus x dx. So what is so special in this? That is, the integral remains the same if the limits of integrals are the same, the function is the same, but the only difference is that we have replaced in this x with a plus b, which is the sum of the two limits, minus x. That is, on replacing in the function x by a plus b minus x, there is no change in the value of the integral. Now, as a special case of this one, we have yet another very important property, which says that if you integrate fx with respect to x from 0 to a, the value is the same if you replace in the function x with a minus x. That is, 0 to a fx dx is equal to 0 to a f of a minus x dx. After that, in the previous video, I had taken up a few questions from the exercise 7.11. Now let's move ahead and take up a few more very important properties. The next property, which we call as P5, says that if you integrate fx dx from 0 to 2a, we can split it into sum of two integrals, one from both from 0 to a. First function is fx dx and the other one is f of 2a minus x dx. That is, 0 to 2a fx dx can be written as 0 to a fx dx plus 0 to a f of 2a minus x dx. Now this property can be proved in two manners. We can start from the right hand side and prove it to the left, or we can start from the left hand side and prove it to the left side. So let's first take up the right hand side. In this, what we have is this remains as it is. We'll only make the change in the second integral, okay, since it is function of a function. So what we do is, in the second integral, if we put this inner function, that is 2a minus x, as t, we'll get minus dx as dt. When x is 0, t is equal to 2a minus 0, which is 2a. When x is a, t is equal to 2a minus a, which is a. Now let's write. So what we get, the first integral gets carried down as it is, plus in the second integral we have, when x is 0 we have t is 2a. When x is a, we have t as a. Now f of 2a minus x can be written as t, and dx becomes minus dt. So minus we write here and dt over here. Now again, in the next step, this gets carried down as it is. Now as we know that from property P1, we know that because of this negative sign, we can, or this negative sign can be absorbed if we change the limits. So we remove this negative sign and change the limits. Change means interchange or swap the limits. The lower becomes upper, upper becomes lower. So we get plus a to 2a ft dt. Now by the first property, which is P0, this variable of integration can be changed to x. So we get a to 2a fx dx. This integral gets carried down as it is. Now since a lies between 0 and 2a, we can use the third property, which is P2. That is, we can combine these two and write it as integral from 0 to 2a fx dx, which is the left hand side. The same way we can start with the left hand side, which is 0 to 2a fx dx. And since a is a point lying between 0 and 2a, we can, using the third property P2, we can split it as 0 to a fx dx plus a to 2a fx dx. This part we already have in the right hand side. So the only part which needs to be simplified or written in a changed form is the second integral. So in the second integral, what we do is, if we put x is equal to 2a minus t, dx becomes dt. And so we get this is as it is, first integral is as it is. Now in the second integral, when x is a, t, when you substitute over here, becomes a. When x is 2a, t becomes 0. F of, in place of x we write 2a minus t. In place of dx we write minus dt. So minus comes outside and dt. Now again this gets carried down as it is. Because of this minus, the limits get swapped. So from 0 to a, this gets carried down as it is. Now we can easily change, function remaining the same, limits remaining the same, we can easily change the variable of integration from t to x. And this is nothing but the right hand side. So either ways we are able to prove this property, that is integral from 0 to a 2a fx dx is equal to sum of two integrals. First is 0 to a fx dx plus the second one is again from 0 to a, but here we have f of 2a minus x dx. Now the next property is a special case of this property only, that is integral from 0 to 2a fx dx is twice of 0 to a fx dx if f of 2a minus x is equal to fx and it is equal to 0 if f of 2a minus x is equal to minus fx. So now what we do is, let's start with the left hand side and we write it as integral from 0 to 2a fx dx. Now using the previous property, it can be easily written as integral 0 to a fx dx plus integral 0 to a f of 2a minus x dx. Now if f of 2a minus x is fx, so in this what do we get? The right hand side becomes 0 to a fx dx plus 0 to a fx dx, which is twice of 0 to a fx dx, and hence we get integral 0 to 2a fx dx is equal to twice of integral 0 to a fx dx. Similarly, if we are given that f of 2a minus x is minus of fx, then on the right hand side what do we get? These two are identical integrals, but one is positive, the other one is negative, so they become equal to 0, and so we get 0 to 2a fx dx is equal to 0, and hence we can clearly claim this property, that is integral 0 to 2a fx dx is equal to twice of 0 to a fx dx if f of 2a minus x is equal to fx, and it is equal to 0 if f of 2a minus x is equal to minus fx. Now let's take up our last property, which says that integral from minus a to a fx dx is twice of integral from 0 to a fx dx if f is an even function of x. And what is the meaning of even function of x? That is f of minus x is equal to fx. That is, in the definition of the function, if you replace x with minus x, the function remains the same. The other property is minus a to a, integral minus a to a fx dx is equal to 0 if f is an odd function of x. That is, if f of minus x is equal to minus fx. That is, a function is said to be an odd function if on replacing x with minus x, function becomes negative of its original form. Now let's take up how to prove this. So what we'll do is we'll first simplify, or we'll first find the value of the integral from minus a to a fx dx. Then we will put the condition whether f is an even function or f is an odd function of x. So let's start. We know that 0 is a point lying between minus a to a, and so we can split this interval into two. One is from minus a to 0 and the other one is from 0 to a using property P2. So this becomes equal to minus a to a fx dx plus integral 0 to a fx dx. Now in this we keep it as it is because it is in the standard form. So let's take up the first integral on the right hand side. So in this, if we put in place of x, if we put x equal to minus t, we get dx is equal to minus dt. When x is minus a, t is a. When x is 0, t is 0. So let's substitute. We get integral from minus a to a fx dx is equal to, now here the lower limit, we know that when x is minus a, t is a, so we write it as a here. We know that when x is 0, t is 0, so we write a 0 here. F of, in place of x we have written minus t, in place of dx it becomes minus dt, so minus we write here, dt over here. Second integral gets carried down as it is. Now here we absorb this negative sign in this integral, and the outcome is the swapping of the limits. So we get it as plus 0 to a f minus t dt, plus this gets carried down as it is. Now again we can easily change everything else remaining the same. We can change the variable of integral from t to x, and so we get integral from minus a to a fx dx is equal to integral from 0 to a f of minus x plus minus x dx plus integral from 0 to a f of x dx. Now we put the condition. If f is an even function of x, we know that f of minus x is fx, and so this becomes two identical integrals which on adding becomes twice of integral fx dx from 0 to a. Whereas if f is an odd function of x, we know that f of minus x is minus fx, and so these two become identical integrals, but this is negative, this is positive, they get cancelled and give us a 0, and so we get integral minus a to a fx dx is 0. And so we can say that integral from minus a to a fx dx is twice of 0 to a fx dx if fx is an even function, whereas it is equal to 0 if f is an odd function of x. Now let's quickly proceed with some more questions from exercise 7.11. Now we'll first take up one category of questions which deal with modulus of functions. Okay, so we have question number 5, 6 and 18 in this exercise which deal with this kind of question, and then we will also do some more questions of similar kind. Okay, so now question number 5 says I is equal to minus 5 to 5 modulus of x plus 2 dx. Now whenever we are dealing with a modulus function, we always redefine it. And how do we redefine? We know that modulus of x plus 2 is equal to x plus 2 if x plus 2 is greater than or equal to 0, that is x is greater than or equal to minus 2. It will be equal to negative of x plus 2 if x plus 2 is less than 0, that is x is less than minus 2. Now after redefining, we analyze the interval in which this function is to be integrated. Clearly we see that this point x equal to minus 2, which is the point of division where the function is defined in one manner on the right of this point and in another manner on the left of this point. So we observe that this point x equal to minus 2 lies within this interval, that is minus 2 lies between minus 5 and 5, and so using property P2 we can split this given integral into two parts, one from minus 5 to minus 2 and the other from minus 2 to 5. Now in this interval we see that when x lies from minus 5 to minus 2, clearly the values of x are on the left of minus 2, and so the definition of the function is minus of x plus 2. So we replace this modulus by minus of x plus 2 in this interval, whereas in this interval, that is when x lies from minus 2 to 5, x is greater than minus 2. So the entire interval is on the right side of minus 2, and so the definition of the function is x plus 2. So in this interval we write, in place of modulus we will write plus x plus 2. Now this is a simple case of integrals which can be easily evaluated. We open this. First of all, we apply the integration. You get minuses as it is, x squared by 2 plus 2x, and since there is a minus sign, both become negative. You apply the limits, plus again x squared by 2 plus 2x, and you apply the limits, substituting the upper limit minus the lower limit. So here this becomes minus 4 upon 2, minus of minus 2 is plus 4, minus you apply the lower limit, so minus 25 by 2, minus of minus is plus 10. Now here we get 25 by 2 plus 10 minus, when you apply this limit you get 4 upon 2 minus 4. Now you open this and solve, you get ultimately 29 as the answer. Same way we can take up question number 16. So it is from 2 to 8 modulus of x minus 5. So first thing, we will first redefine modulus of x minus 5 as x minus 5 when x is greater than or equal to 5. Here I have written it directly. Actually x minus 5 should be greater than or equal to 0, which gives us x is greater than or equal to 5. Similarly, it is equal to minus of x minus 5 when x minus 5 is less than 0, which gives us x less than 5. Again 5 lies between 0 and, as 5 lies between 2 and 8, and so this can be split into two integrals. From one is from 2 to 5 and the other is from 5 to 8. Now we start analyzing. In this interval 2 to 5, the value of x is on the left of 5, and so the modulus will be replaced with minus of x minus 5, whereas on the right, in this integral or in this interval from 5 to 8, all the values of x are on the right of 5, and so the modulus will be replaced with plus x minus 5. And now after removing the modulus, we simply have to apply integral and apply the limits of integrals to get the result. Now let's take up some few more examples. Okay, suppose the integral was from 3 to 7, modulus of x plus 5 x plus 5 dx. So first we redefine x modulus of x plus 5. So what do we get? It is equal to x plus 5 when x plus 5 is greater than or equal to 0, which gives us x is greater than or equal to minus 5. It is equal to minus of x plus 5 when x plus 5 is less than 0, that is x is less than minus 5. So now we observe that minus 5 is less than 3 and minus 5 is less than 7. So minus 5 is on the left side of the entire interval 3 to 7. So minus 5 does not belong to this interval 3 to 7. And so in this entire interval, the value of x is on the right of minus 5, and so there is only single definition of the function, that is plus x plus 5. So the modulus gets replaced with x plus 5 and the limits remain the same. You simply solve it and get the result. Same way, if we have the another function, let's say I is equal to from minus 2 to 1 modulus of x minus 2 dx. Now let's redefine it. Modulus of x minus 2 is equal to x minus 2 if x is greater than or equal to 2. It is minus of x minus 2 if x is less than 2. Now again we observe that 2 is a value which is more than both minus 2 and 1. So 2 is greater than 1 and 2 is greater than minus 2. So 2 does not belong to the interval minus 1 to 2. 2 is outside or above this interval minus 2 to 1. And so in this entire interval, the value of x is less than 2. And so we have only single definition of the function, that is minus of x minus 2 in this entire interval, which can be evaluated. Okay, so it means that it's not always that the modulus gets split into two or more integrals. It is basically, you have to be very careful about the point of splitting of this definition of the modulus function. Depending upon where this point lies, we will decide whether or not to split the integral or the interval into two. Now let's take up another category of questions. There are two questions, question number 7 and question number 9, which are of the same category. So let's start with question number 7. I is equal to integral 0 to 1 x into 1 minus x raised by n dx. We have, as you can, if you recall, we have already done this kind of questions earlier, but we always did it by substitution. And how did substitution help us? It helped us to change or shift the power from this binomial to the monomial, so that we can apply distributive law and open this and get apply the integral easily. Okay, so in that case we used to substitute this inner function to be t, and then we'll have to change the limits of integrals and everything and then do it. The same motive can be achieved by simply applying this property 0 to a fx dx is equal to 0 to a f of a minus x dx. Let's see how. So let's apply this property. We get the limits remain the same. X gets replaced with a minus x. So here a is 1. So we get 1 minus x, and within the brackets we have 1 minus x raised to power n. 1 and 1 gets cancelled and we are left with integral 0 to 1 minus x times x raised to power of n. So clearly we see that the power has got shifted from the binomial to the monomial, and this is very easy to evaluate. We can use the distributive law to get it as x raised to power n minus x raised to power n plus 1. Now simply evaluate it directly by using the formula for integration. We get x raised to power n plus 1 over n plus 1, and this becomes x raised to power n plus 2 over n plus 2. Apply the limits. We get, on applying the upper limit, 1 upon n plus 1 minus 1 upon n plus 2 minus, now we have to apply the lower limit. Both the terms become 0 because at x equal to 0 both are 0. Now simply take the LCM and solve. We get 1 over n plus 1 into n plus 2 as the answer. Exactly on the same way, same lines, we can do question number 9 also. Here it is from 0 to 2, x square root of 2 minus x dx. So square root can be written as 2 minus x raised to power of half. Again the idea is to shift the power half from this 2 minus x to x. So using the same property as above, that is 0 to a fx dx is equal to 0 to a f of a minus x dx, we get 0 to 2, 2 minus x, 2 minus 2 minus x whole raised to power half. 2 and 2 gets cancelled and we get integral 0 to 2, 2 minus x into x raised to power half, which can be easily opened by distributive law. We get 2 times x raised to power half minus x raised to power 3 by 2, which can be easily integrated, and we can apply the limits of integrals to get the result. So in this manner you can try out other questions also. Thank you.